All right. Yeah, let's get started. Welcome everyone to our first webinar about calcbond. The topic today is AutoFEA. I'm Axel, and next to me is Fabian.
Welcome.
So first of all, I want to give you two rules at hand today. First one, keep the microphone muted, and the second one, keep the camera switched off, please. So that's the only two rules we have today. Yeah, thanks. So our first point is the agenda. We will tell you lots about calcbond. The first one is I give you a little introduction about myself and Fabian about himself, and then we have a small summary about AR engineers, and then we switch to calcbond. I will give you a small introduction about the entire platform. That includes the analytical toolbox, of course, the material cards, the wiki. AutoFEA will come later on with Fabian, and where he goes into detail with all the capabilities that come along with that features. So at the end, we give you an outlook about what we are working on, what you can expect in the next month or this year as new features on the platform. And finally, we will have a Q&A session of 15 minutes and to round it all up.
Yeah, and if you have questions during the webinar, please feel free to enter them into the chat, to the Zoom chat in the group. We'll be reading them out at the end in the Q&A session and then try to answer as many questions as possible within the 15 minutes. And if your question couldn't be answered within that time, feel free to shoot us an email and we can happily then answer your specific question.
Yes. Cool. So about myself, I'm Axel. I'm CEO of AR Engineers. I founded the company in 2010. So we're on the market for 14 years now. 14 years now, yes. And I'm an aeronautical engineer by myself, and worked in the composite industry. I did FEA in my time, and that's what we actually do here at AR Engineers. Next to me is Fabian.
Yeah, hi, Fabian Nowacki. I serve as the head of the engineering team here at the company. I've been with the company for roughly 7.5 years now already, and I am responsible for managing the industrial projects as well as research and development projects. And also I have the technical lead on the calcbond development and will be showcasing the AutoFEA feature in more detail later on.
So as I said, the focus of AR Engineers is lightweight engineering, and that includes for us 95% is composites, right? Composites, FEA, and with calcbond we introduced, of course, the software topic with it. That came along a few years ago when we actually had a development project where we had to investigate adhesive joints and in our FEA models, and we needed methods for that to go into depth with analysis, and we needed to program a lot to actually get that done. And that brought us into the software field as well, into the adhesives and adhesive engineering. And within the years, we did a lot of research with that. And a few years ago, we started developing a software for that we brought into the web. And and this is what we are today. We call it calcbond, you know that. And that's the platform. Here we go. And what's our mission? Our mission is to simplify the use for adhesives on the engineering side. So we want to give you methods and knowledge actually on the platform, so you can do your engineering in-house with the platform. And that includes actually 3 major fields. One is the database for adhesive materials and the knowledge to work with that, and the knowledge to work with calculations on the platform in the wiki. The second field is the actual analytical calculation itself. So we have one area, I'll show that in a minute, where you can undertake analytical calculations, type in your data and go. And the third field is the topic why we are here today, and that's the automated FEA. So I would say let's go online and see how it looks like and try it out. All right, so when you go on www.calcbond.com, you will see this landing page here. And if you scroll down, you see a quick introduction about what you could expect once you have registered on the platform. Here are our cooperation partners, Huntsman, Sika, Kissling, and Sigrip. And further down, you can see some videos that you can click. We have a YouTube channel that you can explore and all that stuff. If you think that's cool and you want to register, you can click on the 30 days free trial. And you will be led to a first field of information. You enter your email address and you have to create a password. You have to confirm your email address from your email account, and then you get to a second input field to enter some more information about yourself, and then you'll be led straight on the platform. We can skip that because luckily we are already registered. So Fabian just quickly enters his information, and here you go. We land on the index page of calcbond, and the platform is organized in a way that you have on the left-hand side your navigation bar with all the different fields and information areas that you can explore. And in the middle, you have the workspace where everything takes place. So first of all, just let's imagine you have just registered and you want to see where all that information went to. You can go to your user portal on the left-hand side, roughly in the middle. And here is your personal data stored, and you could edit and change everything that you have entered in case you want to. And later on, we will come to that later, you could as well, because you started as a free user, as a trial user, and you don't have to pay anything here. And if you don't decide to buy, and that's very important for us too, to say that now there's no trap. If you don't want to get anything on the platform, you will be downgraded after 30 days automatically to a free user, and nothing has to be paid, of course. Once you decide actively to top up or to go to a pro usership, you can do that actively here. You go to upgrade to pro, and then you will let through the process, or simply send us an email. Of course, that's always possible. Okay, so far from the user portal, and let's get top down with all the features on the platform. First of all, as I said, we have the analytical toolbox here. That's very straightforward. Analytical toolbox, that means very simple approach to have a very clear and simple first calculation features, and you enter your data as in your material data, your geometry data, and you can click calculation, and within that half a second you get all the information, summary, what you've entered, and the output, of course, the results, and so on. We have you can, if you want to change something, you can transfer to new calculation, do that again. You can explore your design space because maybe you want to play with the adhesive thickness, for example. You can do that with the design space explorer, or you want to save that. You can do that here with saved results, and you can generate your report here on that button. We will go into detail with all these functionalities on the analytical toolbox in 1 month time, on the 29th of February with the second webinar, but we'll say that again at the end of this webinar. So that's the analytical toolbox. Another very important feature for us is, of course, the material cards section, because here you see our cooperation partners that who provide material input data, material information for their adhesives. So we have Kissling, Sika, Huntsman, and IPS adhesives on the platform. You can explore them, for example, ticking the box here, the first one from Kissling, you take the first one from Sika, just give you an idea of how that would look like. You take one from Huntsman and one from IPS, and then say view data, and you will get an overview of those materials you have chosen on another level, and go and research all that information that have been selected. If you want to use something for a calculation, you can go straight to submit to join calculation. You will be led back to the analytical toolbox with that material. All right. The section AutoFEA and self-calculations will be explained by Fabian in detail. And yeah, I think that's from my side so far. We find more information, of course, here in the legal area where you can read our terms and conditions and all that stuff. One thing I forgot, of course, very important, the wiki. As I said in the beginning, we provide knowledge for not only for our platform that you can use and all the information how to use that, make use of it, but as well in general adhesive engineering information. So if you go on our wiki, you can explore that and go through all these very interesting topics. Let's pick one, for example, result evaluation. If I just scroll down, you see there's a lot of description about what you could expect from the platform, and as well what we do in the background and how you could work with that. So yeah, I think that's from my side. I skip back to calcbond and hand over to Fabian.
Perfect. Thank you very much, Axel. And yeah, so now let's dive deeper into the main topic of this webinar today, the AutoFEA feature. The AutoFEA feature is a very powerful toolbox which enables you to perform in-depth 3D design analysis based on numerical simulation and suitable stress engineering methods for adhesive bonded joints, where we have implemented a set of predefined standardized adhesive bonding applications, which you can choose from to start off with your joint design analysis. So here we have currently 5 different configurations inside the platform, starting with the bonded stud. So imagine a simply bonded fastener onto a planar panel of some type, or 2 profiles being bonded together, or coaxially bonded tubes also can be calculated here inside calcbond. And as well, we have a more complex glazing application here, so a window pane of some sort, a planar window, or also a curved window, which is bonded into a frame, can be parametrically designed and analyzed here. And of course, also the standard single lap joint, which many of you might know from typical lab shear testing applications. This can be calculated inside calcbond, of course, as well. Yeah, so for today, let me showcase you the methodology of AutoFEA with the bonded stud. So if I click on the tile here, I'll be directly directed to the input geometry input parameter section, which is divided into the description of the shape and size, basically, of the bonded stud. So here we have a stud which is, for example, welded onto a circular base plate, which is then together bonded by an adhesive layer onto a base panel, which could be a side wall, for example, in a cabinet, or a vehicle, or a ship, or something similar. Also a roof or overhead bonded panel could also be replicated by this. And on the side, you see the positioning of this bonded stud. So within your defined panel size, you can also select to position your bonded stud either in the middle of the panel or somewhere outside in the corner, as long as it's within the boundaries, which is automatically checked. So for example, let's say we have a main shaft diameter of maybe 8 millimeters. We increase the base plate of the bonded stud to 40 millimeters, and maybe the height to 25 millimeters, so the shaft height here. We'll say, okay, the stud base plate thickness is fine. Maybe increase the panel thickness to 4 millimeters. And maybe let's increase the adhesive layer thickness to 2 millimeters. And maybe decrease our base panel length and the width. As you can see, if these input data values do not fit, you'll get a warning here. So don't worry about typing in anything that doesn't work out. Once you change these to correct values, you can also click on center stud on plate. That will automatically position the stud in the middle of the panel. Next, we have to define our material parameters, of course. So we have 3 components here, with the first one being the substrate material, so the base panel in this case. Let's say we have an aluminum, typical aerospace alloy, and the stud itself, the fastener, may be a standard steel alloy, which we want to bond, for example, with a Sika Power 880, which is a high or higher stiffness epoxy-based adhesive, which is suitable to bond these materials also. And then you can see here the basic mechanical properties that are taken from the calcbond material database and used in the calculation here. If you want to calculate your own specific material, you could also go to the dropdown and select user-defined to type in your own adhesive mechanical properties. But for this demo, let's stick with this product here and move down further to the load section. So every bonded joint, if you want to calculate it, how it behaves under pressure or stress or any other type of loading, you need to define loads and boundary conditions. So here we have two different examples. We have a simple loading situation where you directly apply a force or a moment or a combination of all of those at the bonded stud, in this case along the shaft here. Or you could apply a remote loading if you want to account for distances, for lever effects. For example, if you bond devices with an offset center of gravity, maybe you could do that. But for now, let's stick with the simple loading. And let's say we want to apply a horizontal force pulling on the stud with 250 newtons. We don't want any vertical load here. And we want to say the force is acting right on the top edge here of the component. And also we can apply a differential temperature. So if we want to see how would my joint perform not only under a mechanical load, but also a thermal load, I can increase the end temperature, so the operational temperature basically. And let's say we want to see how the joint performs at 65 degrees Celsius. I can do that, and then this will be implemented in addition to the mechanical force as a boundary condition where the thermal expansion effects of all the materials will be taken into account, and also the degradation of the properties of the adhesive material due to higher temperatures, or also maybe the improvement due to lower temperatures for some types of adhesives. Moving on, we have the supports. So once we have fixed the input data for the forces and the geometry and the material, we need to define some type of loading, some type of supports which holds my components in place, basically. So here we can define different support types on every edge of this base panel here. So let's say we want to fix the left and the right edge with the simple support, so only the lateral and vertical movement is fixed, but rotations may be free. And let's say the upper and the lower edge in this case, only the vertical movement will be fixed, but everything else will be kept free. So once we have defined this, and also don't worry, calcbond automatically checks if your boundary conditions are suitable. So if you would have still rigid body movement, for example, the system will notify you so you don't run into the risk of sending off a calculation request for something that couldn't be calculated. Okay, then you're done, and you simply submit your calculation request by clicking on the big blue button here. And then your submission will be processed, and on the bottom you get an information box which keeps you up to date about the progress. So now the request has been sent to the server and will be worked on back at the AR engineer server in Hamburg. And when the results are finished, you can see them online in the platform. So you can either leave this window open and wait, or roam around freely on the platform in the meantime, and then just go back to your saved calculations area here on the left, where you get an overview table for your analytical calculations that you've done in calcbond. But also, if you click on the second tab, your numerical calculations, so the AutoFEA calculations. And right down at the bottom, I'll see, okay, my most recent calculation is still in progress. And once it's finished, I can have a look at it. For example, in the demo I did before, I just click on the link here of the project name, and it opens up my calculation. And when I scroll down, as you can see here, I have the result overview just as an additional section below my input parameter section, which shows all the statistics of the calculation model. So if you're a little bit more familiar with numerical calculations and finite element analysis, you can check the parameters of the model here. You can also check the most important result values here on the right-hand side. And of course, the visualization of the 3D analysis results for the entire assembly. So the deformation, the stress distribution on the right, also a little bit more zoomed in, and also isolated stress and strain results for your specific adhesive layer. So in this case, the example before was a bending problem. So you can see there's lots of bending going on in the adhesive layer here in the middle, and that is well represented within the stresses. Okay, and if I want to view the results in a summarized document, I can do so by clicking the Download PDF button. And then my PDF report with the specific calculation will be generated and will be ready to view and also to save offline, for example. So here I have a cover page with the most important information about the user and when the calculation was done. I have an interactive table of contents, so I can jump in between the chapters. And it summarizes everything from the setup of the simulation with your input parameters through the material data, the forces and boundary conditions of your components, and then a little more in-depth and specific engineering properties for the adhesive, because of course that's what we focus on calcbond, is the adhesive material and the mechanical properties used for this calculation. And if you choose a manufacturer-specific product, you also get a QR code with a direct product link to the website of the provider to get to know more about this specific product. And then in the AutoFEA report, you get more information on the analysis model with the properties being used for the analysis of the adhesive, the analysis model itself, so the finite element mesh. If you zoom in a little closer, for those who are familiar with FEA, they can check on the model quality, the mesh quality if they want to, and some more statistical values, number of nodes, number of elements. And then finally, of course, the results. So here a little more extensive than on the online interface, the table with the maximum deformation values, stress values, strain values, and the plots, of course, that you've seen before. Moving down to the final page of this section, the inverse reserve factor. So here we provide a specific type of failure criterion which compares a 3D stress state inside the adhesive layer to the tensile strength of the bulk adhesive material, which showcases a range from 0 to 1, which displays that your strength of the adhesive would in theory not be exceeded. And once this value, the IRF, exceeds a value of 1, you would be in the failure range, basically. So this is described here on this page and also in more detail in the wiki. So again, I highly recommend reading through the wiki. We find some general remarks, and on the final page, some important information, some links to the platform, a contact person also for the adhesive material, and a specific link to the calculation. So this is very interesting. Even if you share this document with colleagues, supervisors, or clients, you can directly click this link to get back to the calculation inside calcbond, even if it's from somebody else, as long as you are a calcbond registered user, or just scan the QR code with your phone or with your tablet here. So I'll click on this link here. And now I am back inside calcbond and can view this calculation live. Okay, so that is how you work with the AutoFEA module. I'll now switch back to the slides. Just a second. And there we are. So of course, we've been working intensively in the past weeks and months, and also are still working intensively on some future updates for the platform, with the first one, very exciting one, being the user-defined material cards. So we want to provide not only specific material data for products on the market and given by the manufacturers, but also we want to enable you as a user to set up and save your own material data inside calcbond. So for example, if you have test values for products that are still not provided by calcbond by default. You can upload them and save them and also share them there. So you will stay in full control of who sees the data, and nothing sensitive will be in the wrong hands, basically. So that is very exciting and coming up soon. Then we have an interactive 3D result interface planned and in the final works, where we'll be able to see your specific calculation model inside calcbond more responsively. So you can view the model inside the platform. You can move it, rotate it, zoom into it. You can hide and display different components of the joint. So for example, if you would hide the adherence, you can take a closer look and zoom into the adhesive layer. You can access an extensive range of result types and specific failure criteria depending on the type of adhesive that you are working with. And you can define custom results and display them the way you like, and also integrate them into your PDF report just the way you need them. And finally, we also want to improve the Design Space Explorer by implementing new methods that enable you to quickly perform design studies beyond classical finite element analysis based on machine learning techniques that boost the entire design study process. That'll allow for responsive real-time calculations as you change your parameters, basically. You can study a large amount of variations of your joints within a matter of fragments of your typical study time, basically. And this enables maximum efficiency, of course, for you. So you will be on the way to an optimum joint design within a matter of seconds or minutes compared to your older design methodologies, basically. Okay, so that's it from me, and I'll go back to Axel now to sum it up.
Thank you, Fabian, for that great presentation of the platform live. Actually, you have seen that how straightforward it is on calcbond to get your calculation on the way and get even your report done that you can send around as well. We have seen the wiki that where you can actually explore the platform, but as well study adhesive engineering, and that's amazing. If you want to register for our platform, that's very simple. As we said in the beginning, go to calcbond.com and get or enter your stuff, and you're on. If you after a while decide, okay, after 30 days free trial, you want to go to become a pro user because you want to use the AutoFEA that we have shown today, you will have to be a pro user, and that's I've shown that in my presentation. You go on the portal and enter your credentials, and that's it. You're good to go. And it's on a monthly basis. You pay 250 euros a month, and that's it. And if you after 20 days you think, okay, I've done everything, that's enough from my side, I don't need it the next month, you can cancel the subscription and it will expire towards the end of that monthly period. And then 3 or 4 months later, you think, okay, I need it again, and you go on and book the next month, or you send us an email and say, look, I need it for the entire 12 months, and then we of course can deal with that offline via email. So we offer 30 days free trial to try it really out, and as you've seen in the beginning, there's no payment credentials needed to get a free trial, free usership. And if you don't do anything, this will expire and you will stay a free user. And as you can see here on the feature list, you have still access to the analytical calculation that we will present next time in the next webinar. And you have access to the material cards, and you have access to parts of the wiki. And if that's not enough, always you can sign up for more. And we have a special offer for you here. If you decide you start, let's say you started a 30 days free trial and you decide, okay, I want to try that out and become a proper user for 250 years. That's a no-brainer. Sign up and type in AutoFEA 2024 in the registration process, or send us an email with that code. And we offer you, if you book for a 12 months license, we offer you 10 extra AutoFEA tokens on top of everything. As well, if you need training, we offer, of course, a training. But yeah, just give us an email and we speak about all this. All right. If you want to schedule a meeting with us, just scan in the QR code and schedule your meeting with myself or Fabian, or simply send us an email to axel.reinsch@AR-Engineers. One more announcement, as I mentioned already once or twice, we will have another webinar on the 29th of February. Same day, same time. It's a Thursday, 4 p.m., 16 CT. We will talk about the analytical toolbox and the design exploration. All right, that's it. Thanks a lot. And now we've got time left for the questions and answers. Feel free to type your questions into the chat.
Yeah, right. Thank you very much also from me again. And yeah, remember, if you have questions, please use the chat, the group chat. We will read in there and try to answer as many questions as possible.
That's all right.
Okay,
cool. Yeah, so again, thank you from my side for joining us here in our first webinar. It was a lot of fun to show you our platform. And yeah, stay tuned with us on LinkedIn and maybe through our calcbond newsletter. If you're a calcbond user, or even if not, go on the landing page and sign up for our calcbond newsletter. If you're a user and you get the newsletter anyway, we send it out once a month. The next one will be out in a couple of days, actually, I think, right?
Yeah,
Fabian?
yeah, it will be released next week.
And yeah.
And yeah, also have a look at the YouTube channel. If you type in calcbond on YouTube or calcbond YouTube in Google, you'll directly find it. And we have some videos already waiting there for you. And we will be delivering this recording in a couple of days, probably also. And in the meantime, if you have any feedback you would like to share about the webinar today, maybe you have something that you would like to hear more about in the next webinars, let us know also. Just shoot us an email or give us a call anytime. We'd be very happy to hear about it.
Cool.
All right.
So that's it. Thanks a lot again, and see you soon again.
Yes. Bye-bye.
Bye-bye.